In this problem, we're asked to change the complex number 2 plus 2 radical 3i to the ninth power into the form of a plus bi, where a and b are real numbers. So we're going to begin by writing 2 plus 2 radical 3i as a trig form. So let's start by graphing what 2 plus 2i looks like on the complex plane. So if we go over 2 units on the real direction and then up 2 radical 3 units in the imaginary direction, then this point right here is 2 plus 2 radical 3i in the complex plane. In order to find its trig form, we want to know the radius, r. r is found by taking the square root of the real part, 2 squared, plus the imaginary part squared, so 2 radical 3 squared. So here we have the square root of 4 plus 2 squared is 4 times square root of 3 squared is 3, so 4 times 3 is 12. And so we get the square root of 16, or just 4. And then the angle that we need for our trig form, theta, can be found by thinking of a right triangle here, in which we know that the tangent of this angle is the opposite side, which is 2 radical 3, divided by the adjacent side, which is 2. And the angle for which the tangent is equal to radical 3 is the angle pi over 3. So in trig form, 2 plus 2 radical 3i is the same thing as 4 kis pi over 3. So now if we raise this to the ninth power, we have 2 plus 2 radical 3i to the ninth power. We get the radius to the ninth power, 4 to the ninth power, times the cosine of 9 times the angle, plus I sine 9 times the angle. And so if we reduce that, it's 4 to the ninth power times cosine of 3 pi plus I sine of 3 pi. And that can be reduced because cosine of 3 pi, if you go around pi and then another pi radians, you get to an x value of minus 1. And then sine of any multiple of pi, any integer multiple of pi, is 0. So the answer is negative 4 to the ninth power.